factoring quadratic expressions, factoring expressions that have some sort of variable squared in them. What we're going to look at now is quadratic equations, which, what do you think is the difference between a quadratic expression, or is going to be the difference between a quadratic expression and a quadratic equation? Which one will have the equal sign? Equation, right? Because, it's there in the name, almost. Equation. So because there's going to be an equal sign, that also means that there's going to be something to figure out, something to solve for, some value of x that we're going to try to find. There's going to be answers, basically. Answers for what x is. Okay, so a quadratic equation is any equation that has an x squared term, essentially. It's any equation that can be written in the form ax squared plus bx plus c. So there's a coefficient for the x squared, there's a coefficient for the b, there's this constant at the end, and it equals 0. It's always going to equal 0. If it doesn't equal 0, you should make it equal 0. So that's very important that it equals 0. And that's called standard form, the standard form of a quadratic equation. And there's just this stipulation that a should not be 0, because if a was 0, then that means that this entire thing would disappear and you'd be left with a number times x plus c, which is not really a quadratic equation at all. So a should be some non-zero number. It can be negative, it can be a fraction, I guess, but it just shouldn't be 0. What about b and c? Can they be 0? Yeah, there's no problem with that. In fact, you can see some examples right now. On number 2 and number 3, you might notice there's no middle term, there's no x term, and that's because b is 0, so it doesn't really appear. So it's fine for there to be no middle x term, or even no. This one still needs to be moved around, but you might notice there's no constant term. So it's fine for there to be no x term or no constant term, but the squared term has to be there. Okay. Luckily, if you've gotten comfortable with factoring in the past couple of days, or even just familiar with it, you're already 90% of the way to solving quadratic equations. Okay. So first, let's just look at these. And first of all, do they equal 0 on one side? Okay, so you don't need to move anything around. Now you can just factor each quadratic expression that's on the left of the equal sign. For example, 1, to factor x squared plus 11x plus 30, I'm going to want to find two numbers that multiply to 30 but add up to 11. Can anybody tell me what those two numbers are? Okay, positive 6 or... Okay, yeah, positive 6 and positive 5. Okay, so this right here is x plus 6 as one factor times x plus 5 as another factor. That's just the factored form of x squared plus 11x plus 30. And it should still equal 0 because this is an equation and nothing really changed except for how we were writing the left-hand side. And so now we have it in factored form on the left and it equals 0 on the right. Okay. Now the next step in solving this is going to use something called the zero product property, which you don't really have to understand. But let's say I have two numbers, and I'm not going to tell you what they are. I will tell you that if you were to take these two numbers and multiply them together, the result would be 0. What can you tell about either of the numbers? Yeah, one of them must be 0. Because you can't get 0 any other way other than multiplying something times 0. Maybe they're both 0, but at least one of them is 0. Okay, it's the same sort of thing here. You have two factors, and when you multiply them together on the left, supposedly they equal 0. What that tells you is that one factor or the other must be 0. So you take each factor and you set it equal to 0. And solve each factor individually for what x would be. What x would have to be to make it 0. And you're going to get two different solutions. But they're both correct. Okay. All right, so I'm going to set the factor x plus 6 equal to 0. Then what does that mean x is? What does that mean one of the solutions? Yeah. That means that one of the solutions is x equals negative 6. Okay. If I set the factor x plus 5 equal to 0, what does that mean? Right, negative 5. So these are two solutions for x. And you can check each of these. It is possible for an equation to have two solutions, but it does have to be quadratic. And I'll show you a thing later. Okay, so I'm just gonna say, okay, well, what if x was negative 6? What would happen if I plugged it into this x squared plus 11x plus 30? So I'm just gonna plug in negative 6. I'm gonna square it. I'm gonna add 11 times negative 6. And then I'm gonna add 30. Well, it is 0. Okay. And if I do the same with negative 5, take it and I square it, I add 11 times negative 5, and then I add 30. Well, that's also 0. So both of these values, negative 6 and negative 5, work in the equation to make it equal 0. Now, the reason that this has two solutions is because this is a quadratic equation. So in all the equations that you've seen so far, there's only been one solution, at most. Sometimes there's no solution, but like whatever. But that's because the equations you've been looking at so far have been linear. Okay, so an equation like, I don't know, 2x plus 5 equals 0, it's going to have one solution. An equation like x squared plus 11x plus 30 equals 0 has two solutions. And the number of solutions in an equation has to do with the highest degree that appears. So what degree does the x have here? In this, right, it has a degree of 1. In this quadratic equation, the highest degree of x is a degree of 2. So there are two solutions. How many solutions do you think an equation like this would have? Maybe something like, I don't know. Maybe they're actually less, who's to say, but Well, you're only interested in the highest degree. Yeah, so in this case, there would be 3 solutions potentially. There might be less for various reasons that we'll get into, but we know at most you can have as many solutions as the degree that you have. So these equations right here, these quadratic equations we're going to look at today, they're going to have at most 2 solutions, but there is a potential for 2 solutions there. Okay, so example 2 is a difference of 2 squares. It's, y squared is a square and 36 is a square. There's a minus sign in between them. What is the expression on the left-hand side in example 2? How does that factor? Yeah, it's a difference of 2 squares, so it's going to factor into y plus 6 and y minus 6. And it's still going to equal 0, right? Because you're not actually adding or subtracting or multiplying or dividing anything to the equation. You're just sort of changing the way that the left-hand side is written. But now if you take the left-hand side and set each factor equal to 0, what are your 2 solutions?
6 and -6.
Yeah. Take each one. If you take y plus 6, set it equal to 0, and then subtract 6 from both sides, you're going to get y equals -6. And if you do the same with the other factor, y minus 6, set it equal to 0, add 6 to both sides, you're going to get y equals positive 6. Those are going to be your 2 solutions for y. And you can check this one too. You don't even have to do it in the calculator. You can just be like, if you take -6 and you square it, that's positive 36. So if you subtract 36 after that, like in the equation, then you will get 0. Same thing will happen if you start off with positive 6. Example 3. It's not exactly a difference of 2 squares yet. Yeah, what can you factor out of both terms?
X squared. Oh no, you can factor out 3.
Right, because 75 is 3 times 25, yeah. Okay, so if you factor out a 3, the greatest common factor here being a 3 for the left, that will leave you with x squared minus 25, and the x squared minus 25 part is a difference of 2 squares. And what 2 factors is that difference of 2 squares going to become? Okay, x minus 5 and x plus 5. Or the other way around, it doesn't really matter. Okay, so you're going to take each of these factors, x minus 5 and x plus 5, and set them equal to 0.
What do we do with the coefficient?
3? Nothing.
Nothing?
No. It doesn't really count as a factor. It's not going to lead to a solution, particularly because there's no x in that 3. It's just sort of hanging out. But that is a good question because, there is a slightly similar situation that can come up where it actually will be important to think about what you just factored out. But not in this case, because all we factored out was just a number. the first three, they all equal 0 to start. What do you notice about the next 4 examples? Yeah, right. They're not already equal to 0, so that you're going to have to move a term from one side to the other. In general, whenever you can, you want to keep your x squared term positive. So what that means is, don't subtract 9x squared to get both things on the right. Don't do that, because then you'll have a negative 9 next to your x squared. Instead, move the 27x to the left. Okay, so the right-hand side will now be 0. And the left-hand side, because these aren't like terms they can't combine, is just going to have to be 9x squared minus 27x. Now this doesn't look like the quadratic that you sort of factor using the little x. Is there anything you can factor out of both terms?
9.
Okay, a 9.
9.
Right, not just a 9, but a 9x. And if you factor out a 9x, what are you left with? What remains?
9x minus 3. 3x minus 3.
Right. Just plain x and a minus 3. Okay, well, is that factored?
Yeah.
Yeah, it is. Okay. So definitely, so if it's factored, what are your factors? Name one of the factors. Okay, x minus 3 is definitely one of them. Yeah, your other one is 9x. You don't even have to say the 9 because the 9 is a coefficient. You can just say the other factor is this x. Because that 9 is just being multiplied on there, but you can say either way. It doesn't really matter. Okay. I'm sure y'all are more inclined to say that 9x is the whole factor, so I'll just go with that. Okay, so x minus 3, set that equal to 0. And what's that going to give you? Right, x equals 3. And that is definitely one of your solutions. Okay. If you take your other factor of 9x, or just x, and set it equal to 0, what can you do to get x by itself? Yeah, divide by 9. And you're going to end up with what second solution for x? 0, yeah. 0 divided by anything is still 0. So you can sort of see why it wouldn't matter whether you took the 9 or not. You're going to end up with x equals 0 either way. So just take a second and notice how that was a little different from the previous one, where there was like the 3 in the beginning. The 3 in the beginning didn't become anything. But the 9x in example 4, because it had an x, it led to a second solution. Okay. Right. We're going to deal with these. It's going to be fine. Okay. 2x squared minus 2x. Okay, so here we have 3 terms. It doesn't look like any of them are similar to each other. What should I probably do? Move the 24 to the left, or move both the 2x squared and the minus 2x to the right? Yeah, I should probably take that 24 and move it to the left. And just make sure that, because we want this sort of written in a nice way, to slap on that negative 24, or that minus 24 at the end. after the x squared term and the x term, so that we have it in a nice little sort of descending powers order. And remember that there's an equal sign and that the right-hand side of the equal sign is now going to equal 0. Yeah, this one doesn't look great. It might look at first like you got to take that 2 and multiply it by 24. Do you have to though? Sorry, what's that?
Factor.
Yeah, you can right. You can factor the 2 out. And so you won't have to deal with this as if it were a slide and divide trinomial. If you factor the 2 out, that's going to leave you with x squared minus 1x, or just minus x, minus 12. And x squared minus x minus 12 is much easier to deal with than 2x squared minus 2x minus 24. Okay. This does need to be factored, though. So what are two numbers that multiply to negative 12 but add up to negative 1? Okay, negative 4 and positive 3. So that's what our factors will have. X minus 4 and x plus 3. What happens to that 2 that was in front of the whole thing, that greatest common factor of 2? Yeah, it should still be there. I mean, it's not going to result in anything, but like it should still be there. Okay, but this is fully factored, so you can take each factor, set it equal to 0. That's going to give you two solutions. One of them is going to be positive 4, and the other one's going to be negative 3. Okay, similar thing. Here you got a p squared term and a p term on the left. You've got a constant on the right, so maybe you want to move the constant on the right to the left by adding 2 to both sides. Let's just add that p, or add that 2 onto the end of the p squared and the p term. Now, we can't deal with that 3 by factoring out, because 3 is not a factor of 7, nor is 3 a factor of 2. No. You could still take the 3 and, like multiply it to the back. That's how you would otherwise have to deal with them if you can't factor it out. Yeah, you slide and divide. So we'll slide it to the back. Get the simpler quadratic, p squared plus 7p plus 6. And we'll just try to factor this in that sort of special way that we do. Okay, so we want it to multiply to 6, but add up to 7. 6 and 1, positive 6 and positive 1. Okay. 6 plus 1. But because we slid, we now must divide by 3, that original 3. And we got to see if they reduce. Plus 1 over 3 will not reduce. What about plus 6 over 3? Yeah, that'll be plus 2. So we got to reduce it to plus 2, and then we'll get to use that. So 3p squared plus 7p plus 2 that factors into two things. That factors into x plus 2. And what's the other factor, though? The one that comes from the plus 1 over 3. Yes, 3x plus 1. And that equals 0. That is the factored form of this 3p squared. Oh, it's they're p's, not x's. Okay, but now it's factored. It was a sort of a hairy one, but it's factored now. And we'll just set each factor equal to 0. P plus 2 equals 0. Solving that should give us negative 2 as a solution. And we'll also set 3p plus 1 equal to 0. And that one's going to take a little, maybe one more step than we've seen so far. But what's the first thing I should try to do to solve for what p is? Okay, subtract 1 from both sides. Get 3p equals negative 1. Yeah. Okay, and then divide by 3. So p is going to be negative 1/3. So sometimes the solutions to these quadratic equations are going to be fractional. Particularly if it's one of those slide and divide polynomial that's going to, one answer that's liable to be a fraction. And you're going to see in general that the fractions come from the ones that have like a coefficient, the factors that have a coefficient with the p, because that coefficient is going to cause you to divide later on when you're solving the equation. But just know that it is a possibility. The plane factors are going to lead you to whole number solutions as they have this whole time. Okay. And we'll look at example 7. And then maybe a couple of other ones. Okay, so for in example 7, the left-hand side kind of looks factored, right? There's an x, it's being multiplied by this expression 2x minus 5. What's the only problem, though, with the way that it's written? Yeah, it's not equal to 0. So even though it kind of looks factored on the left, because it equals 12 on the right-hand side and not 0, it's sort of being in this sort of factored looking form is useless. And so we're actually going to have to expand this. We want to take this x and distribute it to the 2x minus 5. So that'll be 2x squared minus 5x equals 12. And then, it's just sort of like the others. You can subtract 12 from both sides. In order to make it a quadratic equation like the rest. Okay. Yeah, because we can't get rid of that 2. Because we can't get rid of that 2 through factoring it out. So we gotta slide that 2 to the back. We're gonna temporarily get the quadratic x squared minus 5x minus 24. And we're going to try to factor x squared minus 5x minus 24. Okay, so two numbers that multiply to negative 24 but add up to negative 5. And no, it's a different pair of factors than that. There's some other ones. It's usually not one. It's not one that we break up 24 into a whole lot. Yeah. It is 8 and 3. They multiply to negative 24, so one of them should be negative. The 8, because we want them to also add up to a negative number. So the 8 should be negative. So we'll have negative 8 and positive 3. And because this is a slide and divide trinomial, we'll divide by that original 2. Okay. Negative 3 over 2 is not going to reduce. But negative 8 over 2 will. Into negative 4. So the available on Monday evening, September 26th. Answer that later. Okay. So the two factors that it's going to become are
X minus 4
right.
and 2x
Mm-hmm.
minus 3? Or plus 3, I'm sorry.
Plus 3, yeah. But yeah, 2x plus 3. And that's what equals 0. That is the factored form of this quadratic right here. And I'm really hurting for space, but nothing. I'm just hurting for space. Just positive 4, I believe. But that is one of the solutions, yeah. And then the other solution? Yeah. Because you're going to get 2x equals negative 3, and then if you divide both sides by 2, you're going to get x equals negative 3 over 2 as your other solution. Okay. Then just these three, and then it'll be a while before we see quadratics again. Or it'll be a while before we deal with factoring again. Okay. Now, in example 8, on the left-hand side, you've got this x squared term, this negative 3x squared, and this constant term, this plus 15, whereas on the right-hand side, you have the minus 12x. You can kind of move things wherever you want. I'm going to go with the aim of as few steps as possible, so I'm going to add 12x to both sides.
So you don't have to divide by 3?
I guess you could divide by 3 to start out, but it would probably be better practice to sort of keep everything the way it is for now and then factor out the 3 later. I mean, it's ultimately going to achieve the same thing. Because I'm moving this x term, where should I probably put it in the order of terms? Should I put it like right here? Right here, right? In between the x squared and the constant term. Okay. And although this doesn't look like it's going to be a nice one, if you do factor out a 3, and more specifically, I would probably want to factor out a negative 3 so that I am left with a positive x squared term. So if I do that, well, then I'll have, first term will be x squared. What's 12x going to be if I take out negative 3? Okay. Minus 4x. Okay. And what's positive 15 going to be if I take out a negative 3 factor from it? Yeah, minus 5. Okay, so it turns out all I have to factor is actually x squared minus 4x minus 5, which is not so bad. Okay, I want two numbers that multiply to negative 5 but add up to negative 4. Okay, negative 5 and positive 1. I don't have to do anything special with those, so I can just use those numbers straight up. Negative 3, there's that negative 3 coefficient in front, but the two factors then are going to be x minus 5 and x plus 1. Which means that my two solutions are going to be what, probably? If you've noticed a pattern, maybe.
5 and negative 1?
Yeah, positive 5 and negative 1. Okay, so far, for these simpler factors at least, the ones without the coefficients on the x, sort of throughout this whole thing, what have you noticed about the factors and the answers that they give? Right, it's just sort of the opposite value of whatever number is attached. Yeah, and that's going to happen if you set something simple like x minus 4 equal to 0 and move the minus 4 to the other side by adding 4. That's what's going to happen. So don't feel like, as long as the factor is relatively simple, like x minus 4 or x plus 3, or in this case, x minus 5 and x plus 1, if your factors are simple like that, don't necessarily feel like you have to go through the actual dance of setting it equal to 0 and adding the opposite number to both sides in order to get x equals 5. You can know just from having x minus 5 as a factor that the solution is going to be x equals positive 5. It's always going to be the opposite sign to whatever number is attached. For the more complicated factors like this 3p minus 1, it's a little more involved in that. It's still sort of, it's the opposite of one of the numbers divided by the coefficient, but you don't have to worry so much about that. Those are less common. But if you see one of your factors as p plus 2, you can skip right ahead to saying then that one of the answers for p is negative 2. Now, example 9, just like example, similar to example 7, it looks kind of like it's factored on the left, but it's not equal to 0. So it doesn't matter that it's that the left-hand side is factored into x minus 2 and x minus 1. That doesn't give us anything meaningful because it's not equal to 0. And that means that, in fact, we have to yeah, FOIL, or, you know, do the box thing and sort of get rid of this nice factored looking thing, just because it's not going to do us any good in the way that it looks right now. So x minus 2 is one of my factors that is being multiplied. X minus 1 is the other factor. X times x times x is x squared. X times negative 2 is negative 2x. X times negative 1 is negative x or negative 1x. Doesn't really matter which one. I'm just going to write this. Negative 1 times negative 2 is positive 2. Okay. Now, well, you could go ahead and write x squared minus 2x minus x plus 2, and then combine it into x squared minus 3x plus 2. You can also just say, you know, hey, these are like terms. I'm going to combine them right here and just put down negative 3x immediately. So you can do that if you're sort of using this box, you know, arrangement. Okay, but this equals 12 on the right-hand side. Okay, so subtract 12 from both sides to finally get it equal to 0. And that 2 and that minus 12 are going to combine to make a minus 10. And it's going to equal 0 on the right-hand side now. Now that's a quadratic. That is equal to 0. Okay. So, and this is actually the last one that we'll need to use this sort of x thing for. I'm almost certain. Yeah, so the two numbers that are going to multiply to negative 10 and add up to negative 3 are negative 5 and positive 2. And given that this is just a regular quadratic, x minus 5 and x plus 2, and that equals 0. Don't forget that this is an equation and that equals 0 is there, at least now. And then set each factor equal to 0. Or don't. You know, just say what you think the solutions are. But you'll get positive 5 and negative 2, hopefully. So with example 10, you might notice that there is a x to the 3 term here. So we'll see how many solutions we actually get. But what number of solutions do we have the potential to get with this x to the 3 kind of equation? 3. So the first thing I'm going to do is I'm going to subtract 8x from both sides, and I'm going to subtract 12 from both sides so that the right-hand side can be 0. And you're definitely free to do this in one step. But I will do this in 2 steps. Okay, and however many steps you take to do it, you should end up with 2x cubed plus 3x squared minus 8x minus 12 equals 0. Okay. Now there are 4 terms here, and there are no like terms to combine. So this is going to be factoring by grouping. Which you saw on your test and all of you did pretty well on. Okay. So you're going to split this down the middle, and you're going to factor each pair of terms. What can you factor from the first pair of terms? Right, you can always factor the lowest power of a variable that appears, and also you can't do anything with 2 and 3, so you're going to factor out an x squared. And that's going to leave you with 2x plus 3. Okay. Now what about the second half? What about that minus 8x minus 12? What can you factor out of there? Yeah, and not just a regular 4, but a negative 4, because we got that minus sign on the 8. We don't want to leave that minus sign to be on the inside of the parentheses. So we want to factor out a minus 4. And if we do that, we thankfully end up also with 2x plus 3, which is sort of the whole point of this thing. Okay, so 2x plus 3 is one of the factors. Yeah, and yeah, let me yeah, and then the stuff that's in the, so the repeated factor is one of the factors. It appears exactly once, and then the stuff in front collectively becomes the other factor. Okay, now that looks like it's only 2 factors. But if you take a closer look at x squared minus 4, can you factor x squared minus 4? Right, because it's the difference of 2 squares. X squared is a square and 4 is a square. What 2 factors does x squared minus 4 become? Yeah, it's going to be 2, because you got to take the square root to get the values that should be in your factors, and the square root of 4 is 2. Okay, so 2x plus 3 is still here. But now, instead of x squared plus 4, we'll have x plus 2 and x minus 2. So ultimately, we have 3 factors, and we're going to have 3 solutions. And that's all because this is a cubic equation. Even if we solve it in, pretty much the same way, just through factoring. It's a cubic equation, and so we're going to end up with 3 solutions. 2x plus 3 equals 0. Subtract 3, 2x equals negative 3. Divide by 2. So you're going to end up with negative 3 halves as a solution. And I'm not going to go through the trouble of setting these other ones equal to 0, but you're going to end up with negative 2 and positive 2 as well. And you can totally write your solutions like this. Instead of writing 2 statements that x equals, or instead of writing multiple statements that x equals various values, you can just write a comma-separated list of all the values that x equals, or that x can equal, to make this true. Okay. I'm going to run to recall this real quick. was a lie. I didn't run. Okay. And now in preparation for something we're going to talk about tomorrow, we're going to we're going to appear to switch gears for a little bit and talk about simplifying square roots instead.
We can just put these in our calculator.
Not all of them directly. Yeah, you can put these in your calculator if the answer turns out to be a whole real number. Which some of these are. But before we talk about square roots, let's talk about squares for a second. What's 1 squared? 1, right? Okay. And just a reminder that squaring something is multiplying something by itself. 2 squared is 4, because 2 times 2 is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25, right? 6 squared? 36. Okay. 7 squared? 49. 8 squared? Okay. And we'll just do 2 more. 9 squared? 81. And 10 squared? I think we all know this one. 100. Yeah. Actually, here's 2 extra ones for you. 11 squared is 121. And 12 squared, 144. That number actually comes up a lot. If you deal with things that are like in dozens, it's called a gross. The number 144 is called a gross. Okay, so these numbers on the right-hand side, these are known as the perfect square numbers because they are the squares of whole numbers. And of course there are more, right? There are infinitely many because you can take any whole number and square it. You can take, 1,317 and square it, and the resulting number would also be a perfect square. But these are the first 12 perfect squares. Okay. Now, and you don't actually have to write this part down, just sort of understand that this is the relationship between these numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 11, and 12, and these numbers 1, 4, 9, 16, 25. Square roots are like the opposite of squaring. So that means if the square root of 1 is going to be 1, okay, sure. I mean, that's not like that reveals a lot of information. The square root of 4 is the number 2. Square root of 9 is 3, the square root of 16 is 4, and so on. Right, so the square root of these square numbers is going to be whatever number you had to square in the first place to get them. So what will be the square root of 49? Okay, so this is 7. It just is 7. Yeah. Okay. This negative isn't going to really change anything about how you think about the square root of 100. It's just going to know that it's there. But what is the square root of 100? 10. Okay. And so this part, right, this part is 10. And this part is negative. This part is just a negative sign. So your result is negative 10 because the square root of 100 part becomes 10. Now the square root of 16/36, the way that square roots work, you can actually distribute them over the two parts of a fraction. This is going to be the same as the square root of 16 over the square root of 36. So what is the square root of 16 and the square root of 36? 4 and 6. So this is going to be 4 over 6. Could you simplify? Into 2/3. Okay. And so yes, you would.
Okay, I was freaking out for a second.
What do you notice about these numbers? 8, 200, 60, and 75, as opposed to 49, 100, and 16, and 36. Yeah, they're not perfect squares. They're not going to be on this list of perfect squares. So there's going to have to be some other way to deal with these. And the way to deal with these, easiest way to deal with these, is to try to break up these numbers into a square number and whatever else is going to be left if you take out a square number. But you want to try to get a square number from inside of 8, from inside of 200, from inside of 60, and inside of 75. If you think of all the factors of 8, is any one of them a square number? 4. 4 is a good one. 1 is always going to count, but like, not that anyone said 1, but just in case anyone was thinking it, 1 will work, but it's not going to help you at all. But 4 is definitely a factor of 8. What's the other factor got to be if one of the factors is going to be 4? 2. Okay, so we'll just break this up into 4 and 2, keeping them underneath the radical for now. So just 4 times 2. Okay. Now again,
that would be the answer?
no. Almost though. In the same way that we're able to sort of distribute the radical, and that's what the square root symbol is called, a radical. Radical also just means root in like Latin-based languages. You can also distribute it between each of a number of things that are being multiplied together. So the square root of 4 times 2 is equal to the square root of 4 times the square root of 2. And this is the reason that we wanted one of the factors to be a square number, is so that we could simplify it in this way. What is the square root of 4? 2. Okay, it just is the number 2, right? No more square root symbol for the, this 4. It just is 2. And the square root of 2, there's not really anything we can do with it, so it's just going to have to stay how it is. So it's 2 square roots of 2. And if you actually go to your calculator and type in the square root of 8, and then go ahead and type in 2 square roots of 2, you'll find that they're the same thing. They're just 2 ways of writing the same numerical value. And if you were to actually take 2 square root of 2 and multiply it by itself, in effect squaring it, 2 times 2 is 4. Well, here, you don't actually have to do this part, but the square root of 2 and the square root of 2 would become not doing a great job explaining this. Okay. You've got a 2, a square root of 2, and another square root of 2. These will become 2. If you multiply square root of 2 times square root of 2, it's just the number 2. Then you have these other 2's that were here before. So you have 2 times 2 times 2, that's 8. 2 square root of 2 is literally the square root of 8. Because if you take 2 of them and you multiply together, you get 8. Okay. Is there a square number that you can think of that is a factor of 200? 100, yeah. And there are others. 200 has, 4 as a factor. It has 25 as a factor. It doesn't have 16 as a factor. But it does have 4 and 25 as factors. But whenever you do this, you want to get the biggest square number you can. And I'll show you what happens if you don't. It'll still be fine, but I'll show you what happens when you don't. Okay, so 100. 100 is the biggest square number you can think of that's a factor of 200. What's the other factor then, if one of the factors should be 100? 2. Okay, so then we'll just break this up into two things, the square root of 100 and the square root of 2. And what is the square root of 100? The whole number 10. Make sure not to accidentally carry the radical over. It just is the whole number 10 now. And the square root of 2 is still the square root of 2, because there's no way to simplify that. Okay. Now, if you forgot that 100 was a square number, and you instead tried to use like the 25 or something, let's say you did 25. That's 200 is 25 times 8. And you could do the same process with the square root of 25 and the square root of 8. But you might notice that 8, we just did it last time, there is a simpler way to write 8. So there is still a square number hiding inside of that 8, and it's a 4. So you would have to repeat the process with 8. So square root of 4 is 2, square root of 2 is still square root of 2, and you just end up with 10 square roots of 2, except you have to do this thing 2 times. And that's going to happen if you don't grab the biggest square number factor that you can. Okay. For this one, just remember that this negative sign is here. If a negative sign is outside a radical, it doesn't mean anything.
Mr. K, can we do one more of these, and then can we do these, like one or two of these that we have on this page before we leave?
Yeah, we'll definitely hit that before we leave. Okay. We'll do examples 8 and 9. Okay, so what square number can you grab out of 12?
4.
4, okay. 4 and then 3. That's the square root of 4 times the square root of 3. The square root of 4 is 2. So that's 2 square roots of 3. What square number can you grab out of 90? 9, right. And then if one of your factors is 9, what must the other factor be? 10, and you know that you've done that right because there's no square number you can grab out of the remaining 10. That's how it's going to be. So there's a negative sign in front. Just remember that there's that negative sign in front. Square root of 9 times the square root of 10. And what whole number is the square root of 9? 3. So this is going to be negative, why is there so little space? Negative 3 square roots of 10.
I was wondering the same thing, Mr. Cody.
All the rest of these ones, even the ones that we skipped, are gonna be done in a similar way. The only exception is example 11, which, because 22 is just made up of 2 and 11, and, you know, like, as its best factorization, and neither of those are square, this actually is the simplest way to write it.
So basically, if you have a number like that, like 33.
Right, that
those
only
kind of
has,
numbers, okay.
yeah, that if you have anything that doesn't have a square number as one of its factors, it's already going to be written in its simplest way.
So like number 10, is that one written?
Actually, number 10 can be written as 49 times 7. No, that's not right. It is holy crap, it is 81 times 3. Yeah, I was thinking of 343, which is something else. But yeah, square root of 81 times the square root of 3, so 9 square roots of 3. Six is going to be 4 times 15. Example 7 is going to be 25 times 3. And just remember that the negative signs are there. Now, there were negative signs in front of some of these, but like, you know, they were just in front of the radical, so they ended up just making the result negative. If your negative sign is, where are the negative signs instead?
Inside.
Inside the radical. If your negative signs are inside the radical, you don't have to worry too much about it. All it means is that your result is going to have the letter I tacked onto it. And the reason for that is because, even though I've already accidentally highlighted part of it here, there is this number or this idea of an imaginary unit in math. That is the square root of negative 1. So because that negative sign, you know, for these examples, that negative sign is underneath the radical, and, you know, negative 1, you know, any negative underneath the radical resolves into I, your results are just going to have an I at the end. That's really all it's going to come down
So
to.
it'll just be the answer with an I.
Right,
Okay.
right. Okay, so,
So the square root of 25 is 5.
yes.
So it'd be 5i.
Yeah.
Okay.
Okay. And this I thing really does exist for a reason. Sometimes you really want a number that if you square it, you can get negative 1. That's the whole idea of this. You know, if you take this equation and you square both sides, that means I squared. That means negative 1 equals I squared. There are applications out there where you want a number that you can square to get a negative number. Because normally you can't get a negative number through squaring, right? Usually squaring only gives you positive numbers.
I really wondered who came up with all of this stuff.
Yeah.
I mean, I can think of a few people off the top of my head, like mathematicians, but like, can you imagine just sitting down and coming up with all this stuff, Mr. K?
Not me. That's why I didn't get a PhD.
Yeah, me either. At least you're honest.
Yeah, I mean, I can do stuff that other people come up with, but I cannot, like, contribute original knowledge.
Mm.
Okay. Okay, so let's think about the square root of negative 27. Now there is that negative underneath the radical, so what's our answer going to have on the inside of it? An I, okay. Now let's just think about the rest of it. Yeah, so let's see. How should I split this up? 3 times 9, right? So negative 9 times 3. And I'll just have... You can either remember that the negative sign is going to give you an I at the very end, or you can actually factor out a separate negative 1 factor. When you do this.
So with this one, it would be negative 9. Wait, what? Why is that 1 right there?
It's the negative sign.
Oh.
Like it's not really there for the 1, it's there for the negative sign. But I just can't
gotcha.
have like square root of negative sign. You could if you wanted, but like, you know.
So it's going to be negative 3 square root of 3i?
It won't be negative.
Wow.
Because because it's not, there's no negative in front of here. The negative is underneath the radical and it's what makes the I.
Okay, I understand.
Oops. Write it down.
But the I has to go before?
It can go in any order. I would probably prefer something like this. Make sure that you're not putting it under the radical that's meant for the 3. Yeah. But yeah, like you don't actually have...
I go at the end.
Yeah, I would recommend that you place the I at the end, or you can even have like 3i square root of 3. Like visually, that's a safe place to put it because you won't accidentally put it under the radical. It also doesn't look as weird as having it in the front, but also just having the I in between the 3 and the square root of 3 it looks a little weird. But this is actually like what we've recommended in the past, just so people don't accidentally stick it underneath the radical there. Okay. There's a negative underneath the radical in example 14. So what does that mean that your solution is going to have? An I. Is there any way to simplify the square root of 6?
No.
No. So this is just going to be the square root of 6 I. Making sure, again, that the I is not underneath the radical. You can also write I square root of 6. It doesn't matter. Past that, I mean, a lot of these are going to be the same as the ones before, just with the addition of, I.
So what if it has a negative outside and a negative inside? Does that make it a positive?
No. No, the negative inside and the negative outside serve different purposes. The negative inside, as we've been seeing, will result in what? An I. The negative on the outside, as we might have seen before this, like way in the back, will simply make the result what? A negative. Yeah, so if you have both a negative on the outside and a negative on the inside, all that means is that your result is going to be negative, but it's also going to have an I. The negative on the outside is what makes the negative. The negative on the inside of the radical makes the I. Okay, so what square number is a good factor of 48?
16 and 3?
Yeah, 16 is a good one, which means the other factor is 3. Off to the side, I'll just do a plain old square root of 48, and then I'll write that as the square root of 6 here. Actually, this is probably how I should have been doing it all along. we need to, okay. Break that up into the square root of 16 and the square root of 3. And what whole number is the square root of 16? 4, okay. Square root of 3 remains square root of 3. No way to simplify that, so that just is what it is. So we're going to have 4 times the square root of 3, but we're also going to have what in front? A negative and an I in the back, yeah. Oh my god. Ugh. Okay, I mean, again, all these are very similar to one another. Okay. Let's skip example 16. Let's do example 17. Okay. First, let's deal with, let's just deal with the number 150. What square number is a factor of 150?
25.
Okay, yeah, 25 is in fact the biggest square that's going to fit into this. What's the other factor then if one of the factors is 25? 6, right. I don't know why I asked that. It had already been said for many seconds. The square root of 25 is the whole number 5. Square root of 6 is just square root of 6. So we're going to have 5 square roots of 6, but yeah, a negative because of this negative sign in the front of the radical. What else am I missing? What else? Right, because of this negative sign underneath the radical. Oh, God. All right, yeah. If you want, the other ones are 9 times 7, 20 is 4 times 5. 32 is probably best as 16 times 2, and 125 is 25 times 5. If you ever, if you get home and you want to fill in the blank spaces. And then the last thing we have to deal with is just simplifying the expressions, these expressions that deal with, or that contain, these radicals inside of them alongside some other things. And we'll just leave this stuff until tomorrow, like the rational equation stuff. So no, like not this stuff, like the stuff that's on the back 2 pages. Yes, 9 and 6. So the square root of 54 can be simplified as the square root of 9 and the square root of 6. Yes, it would. And so we'll rewrite that. We'll rewrite that as 3 plus 3 square root of 6 all over 3. And we can simplify this a little bit now that the square root of 54 is written this way. You can recognize that all of the terms here on the top and on the bottom, what's inside the radical doesn't matter. What matters is the coefficient that's in front of the radical. But all the terms here are divisible by what? 3. So you can simplify that by taking all these and dividing it by 3 on the top and on the bottom.
So it just leaves you with the square root of 6. Just 3 divided by 3 is...
Still 1.
Oh, okay.
Still 1. But it's going to be 1 plus 1 square root of 6 over 1, or, you know, just 1 plus square root of 6. So that's one way to deal with them, and you know, that's reducing them. Another way that you could go is you could literally, you can split up numerators. So
It would be 1 plus 1?
it would be 1 plus 1 square root of 6, because that 3 that's right there is a coefficient for the square root of 6.
Oh, okay, I see the first part.
You can also split it up into 2 separate fractions. And simplify each fraction. You end up with the same thing either way. Okay. So in simplifying the square root of 44, what square number fits into 44? Yeah, and then
11 times 4.
yeah, so 4 and then 11. Square root of 4 is 2. 11 is, you guys already got your homework, that's right. I probably shouldn't have done that. Giving out the homework in the beginning, because then people can just leave.
No, that wasn't funny. They said this time.
Yeah. 737. Okay, so the square root of 44 can be written 2 square roots of 11. And so we will. 4 minus 2 square roots of 11 over 2. And again, you can split this up. And here's what that would look like. 4 over 2 minus 2 square root of 11 over 2.
Oh, you can't, can you flip it around and have the square root in the front? Or it doesn't matter?
Uh,
Does it matter?
you can,
'Cause I got 4 minus square root of 11 times.
oh, like that? That's, I guess there's nothing wrong with it, but it's extremely, like, atypical. Normally, the whatever, if you're multiplying a radical by something, usually the thing like the 2 goes in the front of the radical. Almost as if it's a coefficient for an x or a y or something. Okay, so 4 over 2 is 2, and 2 over 2 is 1, so you end up with 2 minus, 1 square root of 11. You can also, recognize that each of these terms right here, the 4, the coefficient of 2, and the 2 on the bottom are divisible by 2, and go ahead and divide them all by 2, you'll end up with the same thing. Okay, and we'll do this one at least because this is an imaginary one. 24 is probably fine, and 25 is kind of like 23. Okay, so the square root of 18. Well, let's say the square root of negative 18. Okay, square root of 9, square root of 2, and what is there going to be? Well, what is there? Oh, sorry. It is going to be 3 square roots of 2. It is going to be 3 square roots of 2. But there's also going to be an I. Yeah.
And then a 3 plus, right?
Yeah. So 3 square root of 2 I. So 3 plus 3 square root of 2 I, making sure the I is again not under the radical. All divided by 6. Okay, so again, you could split this up. 3 over 6 plus 3 square root of 2 times I all over 6. And you could say that that reduces to 1/2 plus 1 over 2. So square root of 2I over 2. That's definitely an answer. You could also say, hey, all these things are divisible by 3. Which for me, I think is, better and easier. So I don't know why I didn't do it more often in the past 10 minutes. Why did I write 2? I mean 3. So that's 1 plus 1 square root of 2I over 2. And you can, the one that's right there, like in front of the radical, is sort of operating as a coefficient. And, in the usual way as when 1 is a coefficient, you don't actually have to write it. So you can just write 1 plus the square root of 2 times I all over 2. And so either of these ways of writing it is good.